Let's start with the simplest type of stoichiometry problem. This is a mole-to-mole stoichiometry problem. And what we'd like to know here is how many moles of hydrogen gas are needed to prepare 312 moles of ammonia, which is NH3. First, we should take a look at the balanced chemical equation. The coefficients in this balanced chemical equation are going to be our mole ratios, and we can use them to figure out how many moles of hydrogen we'd need to prepare this certain amount of ammonia. So just remember the coefficient in front of the nitrogen is a silent 1. Okay, the coefficient in front of the hydrogen is a 3, and the coefficient in front of the ammonia is a 2. What this means is that 1 mole of nitrogen gas plus 3 moles of hydrogen gas will give us 2 moles of ammonia. These are the ratios I will be using to solve the following two problems. So let's take a look at this first problem. Let's start with what we were given in the problem, 312 moles of ammonia. Remember, ammonia is NH3. What we do is we go up to our balanced equation and we find the ratio that puts what we want over what we have. Now what we want is to know about hydrogen moles, and what we have is ammonia. So I'm going to put hydrogen moles on the top and moles of ammonia on the bottom. You can see that the ratio that I'm using is a 3:2 mole ratio, and that came directly from the 3:2 mole ratio in the balanced equation. Now I simply solve by multiplying by 3 and dividing by 2. My answer is 468 moles, and my unit is moles of hydrogen gas, because that's what I was interested in solving for. A nice way to check your answer is to make sure that your units cross out. You can see that I started with moles of ammonia, and that was in my denominator of my conversion factor, and it crosses out. I'm left with moles of hydrogen, so I know I solved the problem correctly. Let's try the second problem. How many moles of ammonia can be prepared using 45 moles of nitrogen gas? Again, we start with what the problem gave us, 45 moles of nitrogen gas, which is N2. We're interested in how many moles of ammonia, so we look at our mole ratio from the balanced equation. And I can see that I can form 2 moles of ammonia for every 1 mole of nitrogen that I put in. Make sure that my units cross out. Moles of nitrogen, I started with those. If they cross out, I'm left with moles of ammonia, which is what I want. And 45 times 2 is 90. Don't forget units, it's 90 moles of ammonia. These are two great examples of mole-to-mole stoichiometry.